As an engineer, I like to solve problems, and losing Wi-Fi during a power cut, that's a big problem. No email, no streaming, no scrolling endlessly through memes. Just me and the horrifying thought of going outside. So I decided enough is enough. If the power gonna play game with me, I will play back. I built a backup power system to keep my internet running no matter what. My Wi-Fi has never been this ready for any apocalypse. To prepare for the end of the world, I will need a battery pack. I am going to make a simple battery by using 3 lithium-ion cell and a BMS. I have 3D printed the holder for 3S battery and made the necessary connection to turn them into a 12-volt battery. Here each cell is 3.7 volt and currently they are fully charged, so it's showing around 4 volt for each cell. Let's check if all the connections are made correctly and I didn't solder them in wrong order. Not saying I have ever done it, I am an engineer, I know what to do. Now I will start adding a 3S BMS to this pack. Battery management system help to charge and discharge every cell in a battery pack in a balanced manner. If not done properly, you can damage your battery and completely damage a cell or two. We have damaged pretty expensive lithium polymer batteries by over discharging them. Solder the ground of the BMS to the negative side of the battery. 4 volt point to the positive terminal of the cell 1, 8 volt to positive terminal of cell 2 and 12 volt to positive terminal of cell 3. I am just cross checking here. Now gonna add this terminal connector to the positive and negative terminal on BMS, from where I am going to take output and when it's not in use, charge the battery. My nuclear reactor is ready to power my Wi-Fi. Now we need to design a control circuit which is going to allow my power supply to automatically switch to battery power when we have a power cut. Here we have a main power which is from the regular 12 volt power adapter of the Wi-Fi. I will hook up this on breadboard. Here I have secondary power which is from the battery pack I made earlier. I will also hook it up on different side of breadboard but keeping them isolated from each other. I will use 2 capacitor on both sides to eliminate the noise from both power supply. I am using a relay here as a switch to switch between primary and secondary power automatically. Let's talk about the circuit in detail. Main power from the power adapter is connected on normal open terminal of the relay. Secondary power from the battery is connected on normally closed terminal of the relay. Here I used a 7805 voltage regulator to convert 12 volt DC into 5 volt DC. Because the relay I had is a 5 volt relay, that's why I am adding this extra component. So how it works is when we have primary power, it also turns on the relay, which result in connecting normally open terminal and common. I am using common as output, so the power will flow from primary to output. I use a Schottky diode which will allow our battery to charge and prevent any back current to primary. And when there is no primary power, relay switch off and it allows connection between normally closed and common. During this time, our Wi-Fi is powered by battery and this allows for automatic switching between primary and secondary power. And the output is connected to a buck converter, which I set up for 12 volt. This will ensure safety of my Wi-Fi. I added two LEDs to indicate the output power and primary power. I just like to add LEDs wherever I can. Here I was just testing out my circuit on breadboard before making it permanent. That circuit was working fine, so I transferred that into a perf board and I soldered all the component and necessary connection. These header pins are for the LED indicator, which I will mount on the outer body. This is output port, which is connected to output of the buck converter. This is connector for the battery terminal. This is input from the power adapter. In circuit diagram, I used only one diode, but as you can notice, there are set of two diodes in parallel. This is done to allow more current to flow, as I had Schottky diode rated for 1 ampere only. Buck converter is also soldered on the perf board to make all the connections solid and neat. This is the old enclosure I made, but it was lacking few things, like a hole to add switch which will turn on and turn off the battery power if we need in any case, and ventilation holes to provide cooling to the electronics inside. I realized when I opened older version of the power supply, it was getting very hot inside, so I made all the necessary changes and printed new enclosure. Fix the nut on the new enclosure using my trusted soldering iron. I wanted to use brass inserts, but I used all of them on my other project. Let's get done with the final assembly of the Wi-Fi backup. I have named it KyberCore. Reference? You have to find out yourself. With the help of double-sided tape, I will fix the battery pack, keeping BMS on lower side to avoid any contact with control circuit and cause short circuit. These two wires are going to be connected on control board. I added a switch on battery supply to allow me to turn off the battery pack when sometime I need to restart or switch off the Wi-Fi. Because with backup power connected, if I turn off it with main switch, backup power automatically kicks off. Now I will add the control board in the enclosure and fix it securely with double-sided tape. This is a connector for the primary power. There I will mount a barrel jack connector to provide power to it. One side is barrel jack input and other is a JST connector. I have completed all the necessary connection and mounting, including the LEDs. Now we will give it a final test. Switch is working properly. Now power it with primary power. As I connected the primary power, it's on, keeping in mind our secondary power is off. Now I turn on the secondary power and I will switch off the main power and secondary power to control. And by switching off the secondary power, it's completely off. Here I have added a 1000 microfarad capacitor at output, because when our power was switching from main power to backup, there was a time gap of few milliseconds, and due to that it was causing my Wi-Fi to restart. And this restarting process take nearly 2 to 3 minutes. To avoid this time gap, I have added this capacitor to fill up this millisecond window. Now my final device is ready to be installed.